Welcome to this explainer. Today, we're diving into a truly profound realization. We're going to unpack the idea that a relentless quest for good explanations isn't just some abstract ivory tower academic exercise. No, it's actually the beating engine that drives literally all long-term human innovation and progress. By the end of our time together, you're going to see how the way we formulate ideas quite literally gives us the power to transform the physical world around us.
Let's kick things off with a mind-bending cosmic paradox. I mean, physically speaking, human beings are basically just a sort of chemical scum sitting on a tiny, completely unremarkable rock, orbiting a totally average star. On a cosmic scale, we are microscopic. Yet, incredibly, we accurately understand the violent, wildly complex inner workings of quasars and supernova that are billions of light years away from us. We know for a fact that these distant stars are nuclear furnaces, transmuting base elements into the exact same atoms that make up our own bodies.
But that brings up a massive question, doesn't it? How can we possibly know what's happening inside distant stars when our physical senses can't even come close to reaching them? Think about it for a second. No human has ever visited the core of a star. Our physical experience is entirely restricted to our localized senses. It consists of nothing more than the electrical impulses from the light hitting the retinas of our eyes right this exact second. When you really stop to realize how trapped we are inside our own biology, the enormous sweeping reach of our scientific knowledge almost seems like magic.
Which brings us to Section 1, Beyond the Senses, Dismantling the Old View. To solve this paradox of how we know so much despite our physical limitations, we've got to abandon a very ancient and, frankly, deeply flawed way of thinking. For centuries, brilliant thinkers fell into the trap of empiricism. This is the misconception that human beings somehow derive all their knowledge about reality passively just from sensory experience. People like the philosopher John Locke incorrectly argued back in the 17th century that the mind was like a blank slate or white paper, and that we just passively read knowledge from the book of nature by observing things over and over again. But here's the thing. Observation alone absolutely does not create theories. We are not just passively sitting around observing. In reality, science acts a bit like a reverse conjuring trick. We actively conjecture and intensely seek to understand. We build these massive, complex instruments, like radio telescopes and X-ray detectors, using just Earth's raw materials, stuff like iron ore and sand. And then we use those instruments to essentially fool our limited senses into seeing the hidden mechanisms of reality that simple, passive observation could never, ever reveal on its own.
Moving on to Section 2. What is a good explanation? The engine of progress.
So, if passive observation isn't the source of our incredible progress, we need to look at the single human activity that actually does create knowledge. And the crucial point here is that a good explanation is an assertion about reality that is hard to vary. What does that actually mean in practice? Well, it means that if you try to change its details, you ruin the explanation entirely. It's like a tightly built puzzle. If an explanation is easily variable, like ancient myths claiming the gods made it rain or magic did it, it can just be slightly tweaked to explain away anything. And a theory that explains everything actually explains nothing at all. Seeking explanations that have these tightly interlocking, hard-to-vary parts is exactly what protects us from the dangerous trap of simply fooling ourselves.
The physicist John Archibald Wheeler captured this feeling perfectly. Discovering an explanation that is hard to vary reveals the elegant underlying laws of nature. It injects a real sense of deep beauty and absolute inevitability into human discovery. When you finally find the truth, it feels like it couldn't have possibly been anything else. It just clicks into place.
So, how does this actually build up in the real world? Progress doesn't just come from staring blindly at data. It flows through a very specific step-by-step cycle. We encounter a problem, we creatively conjecture solutions in our minds, we subject those solutions to intense criticism and experimental tests, we replace the erroneous theories, and ultimately, we arrive at a new, even better problem. It's this continuous, dynamic loop. And the best part, the real beauty of this process is that we can let our bad theories die in our place, without having to stake our actual lives on them.
Here's Section 3, the reach of ideas, breaking parochial bounds.
What's truly remarkable here is how good explanations naturally develop a sort of magical property called reach. Because it's so hard to vary, an explanation designed to solve a very local problem automatically applies way, way beyond its original scope. Take the tilt of the Earth's axis causing our seasons, for example. Because that explanation relies on fundamental geometry and physics rather than some local mythology, it automatically applies to other planets in totally different solar systems without ever needing to be redesigned. It has enormous reach. We didn't have to fly out to Mars or extrapolate our data to understand its seasons. The hard-to-vary explanation we created right here in our own backyard already contained that knowledge.
Let's look at Section 4, Predicting V's, Understanding the Spaceship Analogy.
This brings us to a major misconception, the belief that science is merely a tool for predicting outcomes. This is a view known as instrumentalism. But listen, believing science is just about predicting facts is exactly like saying the entire purpose of a spaceship is simply to burn fuel. It's completely confusing the mechanism with the goal. Burning fuel is just the mechanism. The goal is actually reaching the destination. Similarly, predicting data from an experiment is just a mechanism. It's a way to test our ideas. The real, ultimate goal of science is to deeply understand the underlying fabric of reality.
Section 5. Problems are soluble. The power of universal constructors.
By prioritizing deep understanding over mere prediction, our explanatory knowledge becomes an incredibly active tool. It gives us unprecedented, almost cosmic-level control over our physical environment. And in the process, human beings become what we call universal constructors. Think about it. Every other organism survives by finding a specific, naturally hospitable niche. But us, human beings, armed with explanatory knowledge, transform totally inhospitable environments into robust support systems. Through the immense reach of our ideas, we can cause literally any raw materials to undergo any physically possible transformation, just as long as we have the right knowledge. We are limited not by our biology, but only by the universal laws of physics.
Now, of course, as we continue to innovate, build, and push the boundaries of reality, conflicts between our ideas will constantly arise. We're going to make mistakes. It's guaranteed. And this means that problems are absolutely inevitable. We will always face new hurdles, new contradictions, and new unknowns as we expand our reach out into the universe.
However, we have to pair that reality with a complementary and equally important mantra: problems are soluble. Because we possess this totally unique universal capability to create new, hard-to-vary explanatory knowledge, every single problem we face is fundamentally soluble. There is no barrier we cannot cross, no mystery we can eventually unpack, provided the laws of physics allow it. The right knowledge can and will fix it.
Let's pull this all together into what is truly a grand paradigm shift. Number 1, people are universal constructors. Number 2, the universe is deeply explicable. Number 3, problems are inevitable. And number 4, critically, all problems are soluble. This brilliant shift in mindset proves that the true engine of unbounded future innovation isn't about natural resources or magic or passive observation. It is our relentless pursuit of good, hard-to-vary explanations.
As we wrap up this explainer today, I want to leave you with one final, provocative question. Since all problems are solvable given the right knowledge, what impossible problem are you going to solve next? Look at the challenges in your own life, your work, or your community, and seriously ask yourself how you can push human progress forward. It doesn't start with just waiting around for the answers to present themselves. It starts by actively seeking a genuinely good explanation.